Welcome to The Explainer. Today, we're tearing down the high-stakes, fast-paced science of water disaster recovery. Because, let's face it, when water invades a building, it is absolutely relentless, and the response has to be incredibly precise. To really grasp the mechanics of this, we're going to use the coastal city of Revere, Massachusetts, as our ultimate case study. Honestly, Revere is basically a geographical battleground for water, so studying how the experts mitigate disasters there gives us a total masterclass in structural drying and recovery. But before we get into the heavy science of it all, I want you to really think about something for a second. What actually happens in the first 60 minutes after a coastal storm surge breaches a home? I mean, the second that water crosses the threshold, a ticking clock starts. Every single minute that water just sits there, the damage multiplies, creeping into the floors, the walls, and right into the very foundation of the property. The stakes literally couldn't be higher, and the response has to be immediate. So, to see exactly how the pros beat that clock, here is our roadmap for today. We'll quickly cover Revere's unique water hazards, look at the 3 categories of water, explore that terrifying 48-hour mold window, dive into the science of structural drying, and finally, take a property from ruin to complete recovery. Let's get right into it. Part 1. Revere's unique water hazards, or a perfect storm. Let's see why Revere is the absolute perfect testing ground for this kind of disaster. The vulnerabilities here are just totally stacked. Picture this. You've got a coastal peninsula staring right down the barrel of Atlantic nor'easters. Down in neighborhoods like Point of Pines, folks are battling aggressive tidal flooding and king tides, causing serious saltwater storm surges. Then you add in high water tables and combined sewer systems, which are a complete nightmare during heavy rains. And we can't forget the aging housing stock. In areas like Beachmont and Oak Island, you've got these classic New England triple-deckers built way before modern waterproofing was even a thing. When winter hits, those old pipes go through brutal freeze-thaw cycles that can easily burst and flood multiple units overnight. Now, to grasp why that high water table is such a massive problem, you really got to understand hydrostatic pressure. This is the immense force exerted by saturated soil that literally pushes groundwater upward, squeezing it right through microscopic cracks in a foundation. In Revere, especially around Bell Circle and near the Wonderland station, the coastal water table sits just a few feet below the ground. So when heavy rain saturates that sandy soil, hydrostatic pressure turns regular basements into bathtubs, overwhelming sump pumps in a matter of minutes. But here's a vital distinction. Not all water damage is created equal. Typical freshwater flooding? Yeah, it's bad, but those materials can often be extracted, dried out, and saved. Coastal saltwater storm surge, on the other hand, completely different beast. Saltwater is highly corrosive. It attacks electrical systems, completely ruins HVAC equipment, and actually continues to attract moisture long after the floodwaters are gone. Because of this, saltwater damage almost always demands the complete removal and replacement of materials like insulation and drywall. Moving right along to Section 2, 3 categories of water, assessing the threat. Let's look at how the experts figure out their exact attack plan based on what they're dealing with. The restoration industry breaks the hazard levels down into categories 1, 2, and 3. Category 1, that's your clean water. Think a broken supply line or direct rainwater. Low hazard. Category 2 is gray water. Coming from washing machines or toilet bowls, it's got microorganisms and can definitely make you sick. But Category 3 is where things get really dangerous. This is black water. We're talking sewage backups and coastal storm surges. In older Revere neighborhoods, combined sewer systems can easily get overwhelmed during heavy storms, literally pushing raw sewage up through basement floor drains. Handling Category 3 requires highly specialized protective gear and super strict disposal protocols because of the toxic pathogens involved. Next up, Section 3, the 48-hour mold window, which is truly a race against time. So we know what the water is, but how much time do we actually have? What's wild about this disaster timeline is just how short your window is to prevent a massive secondary disaster. Best case scenario, emergency extraction kicks off within that first hour. But look right in the middle there, 24 to 48 hours. That is exactly when mold spore colonization begins. The entire goal of that final 3 to 7 day structural drying phase is to aggressively pull the moisture out of the building before that mold can permanently take hold. I really want to hammer this point home because it happens so fast. Mold spores begin rapidly colonizing within just 24 to 48 hours in damp conditions. That's literally a day or 2. And that is exactly why restoration professionals keep staging equipment ready throughout cities like Revere to ensure a sub-1-hour emergency response time. Honestly, if you wait until the next day to even start pumping out the water, you've already lost the race against mold. Okay, Section 4. Science of structural drying, precision over panic. Let's completely demystify the scientific approach they use once the standing water is gone. Because listen, proper restoration is not just opening a window and pointing a cheap box fan at a wet wall, not even close. It's an exact science governed by the IICRC S500 standards. These are scientifically established protocols that define precisely what constitutes dry for different building materials. Insurance adjusters actually required this standardized approach before they'll ever approve a claim. It completely removes the guesswork and ensures a property isn't just dry on the surface, but dry down to the molecular level. To actually hit those standards, the pros bring in a serious scientific arsenal. We're talking truck-mounted extraction pumps, capable of pulling thousands of gallons an hour, massive industrial dehumidifiers, and high-velocity air movers. But honestly, the most fascinating tool here is the thermal imaging camera. See, water cools down as it evaporates, so by detecting temperature differences, thermal cameras reveal hidden pockets of moisture trapped behind drywall or under floors that are completely invisible to the naked eye. It is literally like having X-ray vision for water damage. So the multi-million-dollar question is, when do you turn all those loud machines off? Well, the S500 standard dictates very specific moisture content levels. For structural wood framing to be considered safely dry, it has to hit a moisture content below exactly 15%. Anything higher than that, and you're leaving the door wide open for structural rot and nasty mold colonies down the line. And for drywall, the standard is way more rigorous. Drywall has to reach a moisture content below 1% before it's officially considered fully dry. 1%. These metrics are measured twice a day with highly calibrated meters, and the equipment isn't packed up until the data definitively proves the building is safe. Finally, Section 5, Ruin to Complete Recovery, the Restoration Life Cycle. Let's map out how a chaotic disaster zone actually becomes a safe home again. This whole crazy, chaotic event is actually managed through a highly structured three-step process that's designed to take the stress right off the property owner's shoulders. Step 1 is the immediate assessment and emergency extraction. Step 2 is the meticulous structural drawing and monitoring we just covered. And finally, Step 3 is complete restoration and reconstruction. After all, you don't just leave a house torn down to its studs. Now, that final reconstruction phase is incredibly regulated. It involves replacing the damaged drywall and flooring, sure, but it also requires coordinating licensed plumbers and electricians. Why? Because Massachusetts building codes dictate that any electrical and plumbing systems compromised by water, especially saltwater or sewage, must be professionally repaired, inspected, and fully permitted. Plus, proper disposal of all that contaminated material is mandated by environmental guidelines. It's a massive, massive logistical operation to return a home to its pre-loss condition. Which brings us to the end of today's explainer, and I want to leave you with this somewhat provocative thought. If a pipe bursts in your walls, or a storm surge hits your neighborhood tonight, is your property prepared for the ticking clock? Understanding the science of water damage, that terrifying 48-hour mold window, and the intense mitigation process isn't just fascinating trivia. It's vital knowledge that could quite literally save your home. Think about your own preventative maintenance, your emergency readiness, and exactly what you do in that first critical hour. Thank you so much for joining me today to explore the anatomy of a disaster, and keep learning.